Today, we are going to see some more interesting and important questions from MS Chouhan's Organic Chemistry, Aldehydes and Ketones Level 1 and the question from 81 to 90. Come on, let us discuss. The first question. The amino ketone shown below undergoes a spontaneous cyclization on standing. What is the major product of this intramolecular reaction? Right. Now here, in this point, keto group it is there, amino group it is there. So in that keto group, carbonyl carbon is available. And nitrogen, amino group, in that nitrogen, lone pair of electrons are available. So the lone pair of electrons, which is going to attack the carbonyl carbon. Okay. So when it is attacking the carbonyl carbon, so the lone pair of electrons, which is going to attack the electrophilic nature of carbon. So that means the first one here, what it is, this is nucleophilic attack. Right. And the second one, lone pair of electrons, lone pair of electrons, that is on nitrogen atom, right? Nitrogen atom on that will be going to attack where it is carbonyl carbon of carbon, right? So that is a keto group which is attacking. So naturally transfer of electron takes place. Here you will get minus charge and here you will get positive charge. Right now, what is the major product? That is only the final idea. We have to check it. Okay. Now come on. Let me give that explanation here with that structural formula. So this is the right now here, this is actually carbonyl carbon and this is CH3. And then same way here, CH2, here CH and here CH3 and then here NH2. Right now, this is only we mentioned, so intramolecular attraction. So hydrogen and oxygen is there. No, so naturally intramolecular reaction. That means intramolecular point, it will be taking place. So right now here, lone pair of electrons, which is going to attack the carbonyl carbon. Transfer of electron takes place, negative charge, here positive charge. So this negative charge, which is attracted towards the positive charge of hydrogen. So 2H plus ions are available. So naturally, it loses water molecule. So what happened when it is loses the water molecule? So you will get the product, major product only they are asking. Right now, this is the, right. So this is carbon, which is attached with the CH3. CH3, it is here. And then here, double bond. Here it is nitrogen because hydrogen has gone over with oxygen, so it loses water. Now here what it is, nitrogen, and here CH2, CH, and here CH3. This is same as it is, right? CH3, and then this nitrogen, which is going to attach. This nitrogen only is attached. So this is the way cyclization formation takes place. I hope you got the clarity. Okay, now here in this point, so the double bond comes where it is. That is the correct order. Easy to identify. So the double bond comes, which point the double bond has to predict. So here that actually they mentioned the double bond over here, the double bond they mentioned here. So the double bond they mentioned here. Actually, ketone already it has gone out of that because it has formed a water molecule H2O. So naturally it forms water molecule. So this will not be the correct option. And the second one here, double bond comes here in middle. So actually where double bond it has to, this double bond goes there to attack means, so that carbon and nitrogen only connectivity, but here actually another, this carbon and what it is, nitrogen, how is it possible to attack? So this is not the correct option. And the same way this also, this is also the not methyl group where it has gone here, because here methyl group it is available, no? So this also. So option D, let us check option D, double bond, it comes on that point what we have drawn, what we have suggested that answer. So the answer has come over here. Of course, methyl group here, I just draw that structural here over. So the same way, 6-membered ring, it has come 1, 2, 3, 4, 5. Right here it has mentioned. So option D is the correct option. I hope you got the clarity. See, that is what already I mentioned, even some other videos also. If you know the correct exact equation, that is concept, if you know, you are able to identify the answer. You don't need to go and check it for other options. Directly you can find which is the correct option. Right now, see, these are all why it is not possible. Option D only is the correct, because easily we have identified the answer through these main points. This is nucleophilic attack and lone pair of electrons. Through lone pair of electrons, it is going to attack the carbonyl carbon. So in that way, carbonyl carbon, why it is? Because it is a electrophilic in nature. So in that way, easily you can bring the answer. I hope you got the clarity. Come on, let us go to the next question. The next question, compound A, C6H12O is optically active. Compound A give negative for tolerance test and positive with 2,4-DNP, 2,4-dinitrophenylhydrazine. So two key points they have given. First of all, the compound, it is optically active. And the second one, that compound will be answerable only for 2,4-DNP and it will give negative test for tolerance test. Right now, let us check with that second key note. It is positive test. Here, this is positive for 2,4-DNP. You know what it is 2,4-DNP? Brady's reagent. Brady's reagent. Brady's reagent is also known as 2,4-DNP. So this compound, that compound A will be answerable for 2,4-DNP, and negative test for tolerance test, tolerance reagent. Right. Okay. Now, which will be answerable for Brady's reagent? That is 2,4-DNP means ketone. Ketone will be answerable. Ketone will be answerable for 2,4-DNP, and it will not be answerable for tolerance test. Tolerance test will be answerable for aldehyde. Okay. Now, this is that one point. Now, let us check which is optically active, which is ketone. Easily we can make out. Then we can bring the answer according to the reasonability. Right now, here this is also ketone, but is it optically active? 1, 2, 3. 4, 5, 6. Okay, C6H12O, right? Okay, now this carbon, which is attached with the 2-methyl group. So, 2-methyl group means, is it optically active? Optically active means the carbon which is connected with the 4 different groups or atoms, right? So that is called, what it is? Chiral carbon, and that is eligible for optically active, right? So this will not be applicable for optically active, though it is a keto group is available. Okay, so this is not the correct option. And then this one, of course, this is 6 carbon is available. Now in that chiral carbon, this is the chiral carbon. How do we say it's a chiral carbon? One side it is a ethyl group, the other side it is a methyl group, the other side it is hydrogen, the other side it is methyl keto group. Yes, it is possible. This is optically active, and the keto group also it is available. And the next one here, this is optically active. Now one side it is ethyl, the other side it is methyl, the one that side it is hydrogen, and this is aldehyde group. Aldehyde group will not be answerable. Of course, here I'm coming to that point. Aldehyde also will be answerable for what it is 2,4-DNP, but aldehyde in that glucose exception. Glucose will not be answerable for 2,4-DNP. Why? Because it is a cyclic in nature, right? So it is locked. CHO group, that carbonyl group, which is locked, that is keto group, which is locked with that cyclic carbon. So here in this point, glucose, right, C6H12O. So here it is a cyclic in nature, so it will not be answerable for 2,4-DNP. See how they have given the question. Easily we can identify if you know the correct concept and clarity. Right now here there is no chiral carbon. Right now option B and option C both are optically active, but option C will not be answerable. Why? Because it is a glucose compound will not be answerable for 2,4-DNP, whereas other aldehydes will be answerable for 2,4-DNP. Yes, that is 100%. But only glucose, that is exception. Though it is a aldehyde group is available also, it will not be answerable. Why? Because it is a cyclic in nature, right? Come on. Now here methyl group, of course, here keto group will be answerable for 2,4-DNP. And ketone will not be answerable for tolerance test. Tolerance test will be answerable for aldehyde group. Here they have given what it is positive test for 2,4-DNP. Yes, this is also correct. And optically active, yes, of course, 100% this is optically active. I just draw the structural formula for you to identify what it is. Optically active. Now here one side it is CH2. Yeah, I just write here CH2, CH3, ethyl group. The other side it is methyl group. The other side it is hydrogen. The other side methyl keto group. Methyl keto group. That is what it has mentioned, no? Methyl keto group, hydrogen. So of course this is 100% chiral carbon, and that is optically active. I hope you got the clarity. Come on, let us go to the next question. The next question here, this compound X and Y combined to give that product that is 99% major product in the presence of epoxide and acid hydrolysis. So what is the product we have to identify from the option? Okay, now first and foremost, this compound, this nitrogen which is attached, right? So this is amine. So this is enamine synthesis. So this is actually, we can say, stock enamine synthesis. What do we say? It's a stock enamine synthesis. Right. Okay. Now, what happened this reaction? Generally, here what it is, lone pair of electrons are available. So the lone pair of electrons, which is going to transfer to the next adjacent carbon. Right now, here what happened? The transfer of electrons, this bond which is transfers over here. Actually, this is a positive charge and this is negative charge. So the reaction comes like this. Okay, let me draw the structural formula for you to understand. So this is actually the compound like this, right? So this is a double bond and which is attached with nitrogen, and this is cyclohexane structure, and here methyl group which is attached. Right now here this is methyl group, it is available. This is double bond which is connected with nitro group, right? Like this way only, right? Okay, now here actually what it is, lone pair of electrons are there. This lone pair of electrons which is transfer over there. So naturally you are getting what it is, the double bond which is transfers over here. So this is a positive charge and here it is a negative charge. So you're getting the compound like this. Here it is actually the bond breaks, right? So the double bond won't be there. So here you will get the double bond, here you are getting the nitrogen. So the transfer of electrons now here nitrogen, but this is actually a positive charge and this is connected with what it is, cyclohexane, right? Cyclohexane. Right now here methyl group which is attached. So now what happened here in this point, like this nitro group which is attached, right? So this is a negative charge, right? So this is methyl group. So here you're getting a negative charge. This negative charge just attached over here. Now this H plus ion which is going to react. Why? Because it is in the presence of acid hydrolysis, right? So that is H plus ion. Now this H plus ion and here minus. So both will get that neutralization reaction. So the minus charge, it has gone, right? Now what is the product you are getting? Like this, you are losing that minus charge and you are getting like this. So here you are getting double bond, same nitrogen, and here it is a positive charge as it is. So the compound comes like this. Right now here it is methyl group and here nitro group, it is available. Hope you got the clarity, but here there is no negative charge because it has taken neutralization. Now water molecules which is going to react H2O. So here lone pair of electrons are available. So the lone pair of electrons which is going to attract towards that electrophile in nature. So naturally here positive charge it is there now, so it transfers of bond formation. So what happened here? Here hydronium ion which is going to attach over there. So here how you will get that formation, here nitrogen and here lone pair of electrons, again it gain back because it is transfer of electrons hit over there, no? So naturally, and here hydronium ion H2O, right? So oxygen and here hydrogen, here positive charge it turns. Right now here what happened, this positive charge, no? So here lone pair of electrons are available. Here it is a lone pair of electrons are available. Here positive charge. So this positive charge is attracted towards that, what it is, lone pair of electrons, right? So what happened here? Like this. Here you will get nitrogen along with hydrogen. So this nitrogen over here, right? So this point which is attached with hydrogen and here methyl group as it is. Okay, now here what happened, this right, okay. Now here this is OH, it is available, and here nitro group which is attached over there. I hope you got the clarity. Now what happened here in this point, here this is actually this point, what I wanted to mention, this point lone pair of electrons are available. No, this formation is actually what it is, ketoenol formation. So this is actually OH enol formation. So it can convert it into keto group. So what happened, this bond breaks, right? So the bond breaks, so you will get that, okay, nitrogen and here hydrogen. So this one and another compound it is, that is a major product, right? So what is the major product? Now let us check here. This is the major product. So you will get the double bond O. See here the enol formation. So this is tautomerism part, right? So ketoenol, this is enol formation. Keto form, so hydrogen it is removal. So here what it is, double bond O. So and here what it is, you will get nitro group which is attached. So this is the major product. I hope you got the clarity. Now come on, let us check which is the correct option. So here in this option A, B, C, D, here what it is, nitro group is there in the edge only. This point it is edge only. But here they have given in the middle, and of course this is cyclohexanone, it's correct, but this is not the correct formation. So option A, we cannot take it as an answer. Now option B, cyclohexanone, exactly it is. And here methyl group which is attached and nitro group is there. Exactly it is the correct option. Come on, let us check other two. And here methyl group, it has to be there in the middle. Why? Because this point which is going to attach over there. So the methyl group, it has to come here, but this is that not the correct structural formula, right? Now, and the same way there is methyl group, it is missing, right? So this is also, we cannot take it as an answer. I hope you got that clarity, which is the correct option, option B only. Why? Because as we gone through this reaction, I hope you got the clarity. How do we get that? This is the way we are getting that option. Okay, so option B is the correct option. Okay, they asked major product only. So the major products, methyl group, I just mentioned in that upwards, it is methyl group, it is there. I just mentioned downwards, right? Yeah, come on. Let us go to the next question. The next question here, pentanone combined with the phenyl magnesium bromide, you're getting the compound N, and in the presence of ammonium chloride along with H2O, you're getting the compound O, and that will be react with the concentrated HCl. In the presence of cold condition, you're getting the product P, and that is reacts with potassium hydroxide 4 molar ethanol, uh, while heating, you're getting product Q. So what is that Q? That only we have to identify. The product Q will be. Of course, this is very simple. See, this is keto group. Keto group, this is Grignard reagent. So Grignard reagent, when it is reacts with keto group. So what is the product you'll be getting? OMGBr. That's all. Simple way. I just draw the structural formula for you to understand. See here, like this, double bond O plus pH. I just put it pH so that it will be easy for us to understand. So MgBr. So you will get that what it is the same way like this. I just draw like this way. So here what it is, you will get here one side it is actually pH, the other side OMGBr. So this point it is pH, the other side OMG. Br. So the keto group bond breaks, right? So now here, this is the product N. This product actually what it is? N. Now this product, which is reacts with ammonium chloride along with water. So what you'll be getting? You'll be getting what it is? pH and OH, right? So H, OH. So here bond breaks. So here what it is? OH will be there. Here H will be there. So that's all right. Simple way. If you know the concept, it will be easy. So here pH, here OH. Right. Now the next one, it's very important. So H plus ion, which is going to react. So H plus ion, that is HCl. So OH will be removed. And that point, you will get what it is, Cl. Right. OH will be removed. So this is actually what it is. OH will be removed instead of that Cl, HCl. So HCl, which is what it is, replaceable. Right now, this is the way the structural formula will be. So one side it is pH, the other side it is Cl. Right. Got it? HCl in that cold condition, concentrated. Yes. Now the last point, what it is? KOH, alcoholic KOH. Right now here what it is? KOH. So KOH, when you're going for it, actually this is while heating, elimination reaction takes place. Elimination. Elimination means what it is? Removal of what it is? Water, right? Removal of HCl, right? Here water we cannot bring it, removal of HCl. So here double bond. So here actually this point it is phenyl group it is there. Phenyl group, what it is? Resonance will be taking place. Now I just draw the structural formula for you to understand. Here the structural formula will be like this. I just draw the structural formula for you. This part, I just draw the structural formula. How that resonance takes place. See here, this is pentagon, right? This is pentagon. Here it is a phenyl group which is attached, right? Phenyl group which is attached, right? Now this is Cl. The same thing only I just draw the structural formula. Right now here what it is transfer of electron takes place. So HCl, it removal of HCl, right? Because elimination reaction takes place, it's KOH, alcohol KOH. So here what happened? You will get the double bond over here. So due to that transfer of bond, that is due to that resonance, you will be getting the product like this. I just draw clearly, right? Now this is actually pH, here you will get the double bond. So this is the product you will be getting, right? Okay, that means here benzene along with pentagon, right? So you will get that double bond over here. So this is the product you'll be getting. Okay, come on, let us check whether this is correct or not. All right, okay. Yes, option here double bond comes to that. Here transfer of a bond, it is next to that. No, so this is adjacent. So this will not be the correct option. So option A, it's not correct option. Option B, exactly the bond comes over here because transfer of electrons like this only. No, so this is actually correct. So this will not double bond where it has to come adjacent bond, adjacent carbon only. No, so this will not be the correct option. And OH actually, how come OH it is possible? Because OH only it has removed by what it is elimination point. HCl it is minus HCl it is removed due to that elimination product. Then how come it is possible? OH has to be present. So this will not be the correct option. So the correct option is B. That is what I just draw the structural formula over here. Right? I hope you got the clarity. Come on, let us go to the next question. So the correct option is option B. Okay. So the next question here, PHCH3. This is actually toluene. Toluene combined with CrO2Cl2. CrO2Cl2 actually it is chromyl chloride. Okay, so this is toluene combined with chromyl chloride. That is a famous naming reaction, right? I hope by this time you will come to know all the naming reaction because naming reaction only indirectly they'll ask question, even for the board as well as for the competitive level. Right now here you are getting the compound A and concentrated KOH. Even here also there is one more naming reaction that is available. Dilute KOH it is there, concentrated KOH it is there. I hope now you got that idea what is the two famous naming reactions you are getting. Right now you are getting the product as well as B. A. This is actually you are getting the product. Another product it is one more product. That product only we have to find out. This is very simple. This is toluene combined with chromyl chloride, that is ETARD reaction. What do we call? This is ETARD reaction, right? ETARD reaction. So ETARD reaction, toluene combined with chromyl chloride. You are getting what it is. What is the product it is actually? Benzaldehyde. Yes. So hydrocarbon, which is converted to aldehyde, that is through ETARD reaction, right? Now this is benzaldehyde. Benzaldehyde combined with concentrated KOH. So concentrated KOH, it is what it is. Cannizzaro reaction. That is another famous naming reaction. I hope you got that clarity. So this is actually what it is. Cannizzaro reaction. So this is ETARD reaction. This is Cannizzaro reaction. So this is dilute KOH. It is actually what it is. Aldol condensation reaction. I think you have learned, right? So by this time you should be thorough, indirectly or directly, all the naming reactions so that it will be easy for you to identify. Okay, so the first one, the first product to A, it is just I will write that PHCH3. Directly I will write it because you know very well CrO2Cl2. So you're getting what it is PHCHO. So this is benzaldehyde. So benzaldehyde combined with the concentrated KOH. So this is what it is Cannizzaro reaction I just mentioned here. So here Cannizzaro reaction, what is the product? PHCH2OH. See, this is primary alcohol. It will be situated over here. So primary alcohol only you'll give. You'll get and you will get connected what it is. Salt also you'll be getting right now, which salt only salt formation you'll be getting. So what kind of salt formation? So that is only here PHCOH. This will not be the salt, carboxylic acid only. So this is not the correct option. Right now here I just change the color. So this will not be the correct option. PHCOO minus. So actually if it is K, if you put it means this is this formation, this product, it is exactly the correct. Come on, let us check other two also. This is benzaldehyde. No, this will not be the correct option. Again, same toluene will not be the correct option. So the option it is salt formation only. You are getting that product to be. So this is the product A and product B. It is actually here what it is related salt. Here benzaldehyde and here what it is benzyl alcohol and what it is potassium benzoate. So that is only you'll be getting right. PHCOOK. So K they did not mention here, minus they mentioned here plus. So K did not mention, so no need to mention here. So this point I just rub out. So this is only the correct option. Okay, so this is the correct option. The option, this is actually B. So option B as the correct option. I hope you got the clarity. See, these are all very simple, and if you know the concept thoroughly by this time, yeah, it will be easy for us. Come on, let us go to the next question. Here, this compound combined with the KCN as well as H plus ion, you are getting the product. The product obtained in the reaction is actually they have given that isomerism way, like diasomer, racemic mixture, meso, and optically pure enantiomers. This point and all I have explained in the isomerism concept only in another playlist, isomerism playlist only. I have given all these ideas. Okay, now let us check how the reaction takes place. Okay, so this is actually what it is. This point here, yeah, this is CHO here, H here, OH here, CH2OH. combine with what it is. First and foremost, you will be getting what it is KCN as well as H plus ion. So first and foremost, H plus ion, which is going to react. Why? Because here lone pair of electrons are there. No? So this lone pair of electrons, which is attracted towards that H plus ion. So you'll be getting that product like the CH double bond O. This is double bond O, no, CH double bond O, H. Right now, this is H, OH, and here CH2OH. Right now, here KCN. So in the KCN, Cn, here minus charge. Okay, so here minus charge, no? So this minus charge, which is going here, this is actually end this point here. This is actually plus charge because CH double bond O, no? So this is plus charge. So which is attracted towards that, what it is, electrophile. And this is nucleophile, right? So what happened? You will get that product like this, Cn, and here what it is? You'll be getting like this CH2OH, here H, here OH, and then same way here H, here OH, right? Okay, Cn it is there now, so here CHOH, no, so another one more line it is formed right now. You just check it. So Cn which is going to attach, so another one more here. You see Cn, HOH and HOH, already HOH it is there, another C, this carbon HOH. Right now here, now this is one more point. This is actually what it is, D plus glyceraldehyde. Here, D plus glyceraldehyde. Now the product only we have to identify. Diastereomers, racemic mixture, meso, and optically pure enantiomers. So optically pure enantiomers, which is not possible over here. And see, in this point, here this one, and here I just draw the another structural formula. Here Cn, and here what it is, CH2OH. So here H, here Cn, right? And here I just are about this point. Here actually what it is, here OH, just changing in that way. So HOH, here CH2OH. So one thing it is common. See, one thing it is fixed both the side. The other one which is changing, so that means it is replaced. So what do we call, instead of going for all these options, this is one it is fixed, the other one it is changing. Spatial arrangement, there is no mirror images, right? So two chiral centers, see, this is one chiral center and this is one chiral center, so both the chiral centers. So this is not a mirror image, cis and trans formation. One it is cis, the other one it is trans. So these are all the part, this character. Where can we identify diastereomers? Only we can identify diastereomers. So diastereomers, you know very well. What do you mean by diastereomers? Diastereomers means it's a spatial arrangement and not mirror images. Cis and trans isomers, it is possible. Minimum two chiral center it has to be. So every points it is available over here. So exact answer, it is diastereomers. Meso means it is what it is. Both are same, it will be like, so that we cannot identify over here. Okay, but here just to the opposite. So diastereomers only it is possible. Okay, so meso it is a achiral, but here it is, we cannot bring that point achiral. Yes, I hope you got the clarity. Come on, let us go to the next question. So A is the correct option. The next question here, pentanone combined with hydroxylamine, you're getting product A. That is combined with H plus ion, you're getting product B. That is reacted with the reducing agent, that is lithium aluminum hydride, you're getting product C. So what is the product C? This is very simple. Come on, let us check this question. Okay, now here in this point, here pentanone, right? Okay, I just draw the structural formula pentanone. This is pentanone, right? So this is double bond O combined with hydroxylamine. H2N, what it is, OH, so hydroxylamine. So you'll be getting what it is, the water molecules releases. So water molecule releases means you will get the product oxime, right? I hope you've got the clarity. So oxime you'll be getting, right? This is oxime, double bond NOH, right? So this oxime reacts with what it is, H plus ion, right? H plus ion, that is what it has mentioned now. So this is the product A, and this H plus ion, you'll be getting the product B. Okay, so what is the product you'll be getting? Here, this is the point you'll be getting. Here, what it is? H plus. So here, lone pair of electrons are available now. So the lone pair of electrons are attracted towards the H plus ion. So you'll be getting what it is, water molecules releases. So N, here O, here one H, and here one H. So this is the positive charge and this is negative charge. So here you'll be getting like this, water molecules it releases. So water molecules it releases means you'll be getting this point, what it is here, like this kind of, you'll be getting what it is, double bond N and here minus charge. So actually here minus charge and here double bond, right? Now this point which is going to attract it towards. So this is actually Beckmann's rearrangement. It is taking place. This point only. This point, what do we call? Beckmann's rearrangement. Rearrangement. Right? Okay. So here what you will get it. You actually Beckmann's rearrangement. It is number of carbon will be increasing. Like this is 5-membered ring, you will be getting 6-membered ring. The position will be changing. Here actually nitrogen which is connected with the double bond. See this point, right? So nitrogen which is connected with the double bond and here 6-membered ring. Right. Now that means here 1 and here 2, 3, 4, 5 and 6. So 6-membered ring. Here it is a positive charge and which is reacts with H2O. Right now in that point they mentioned, So you'll be getting what it is. So I just draw the structural formula for you. So the lone pair of electrons which is attracted towards this H plus ion. So what you'll be getting here, bond breaks. So the bond breaks means here you'll be getting like this. All right. Here nitrogen, here double bond as it is, here O and here H. Right. Okay. So now this is actually tautomerism. This point you will get what it is, tautomerism. So tautomerism, ketoenol tautomerism, right? So here you will get this point. So you will get amide ketoenol tautomerism. I just mentioned here tautomerism. Tautomerism. So here you will get what it is, amide formation you'll be getting, right? What it is, amide formation. This is nitrogen. Here in this point nitrogen will be available, hydrogen, right? Okay, here it is hydrogen. So this is actually amide combination, double bond O NH. It is amide combination. This amide reacts with the, what it is, lithium aluminum hydride. So lithium aluminum hydride. So lithium aluminum hydride, it is a reducing agent. So it converts, keto group can be converted to CH2. Right, keto group converted to what it is, CH2. So I just draw the structural formula for you to understand. Here CH2, this point it is CH2, here N and here H, right? Okay, so this is this point only, what it is, CH2, C double bond O which is converted to CH2. Here CH2 it is there, no? So this is the product you'll be getting. Here CH2, I just mentioned here CH2. Okay, now option, which is the correct option. So the correct formula, that compound, it is like this, NH. Right now this is the product you will be getting with this reaction. Okay, so which is the product? The product it is A, B, C, D. So A, OH is available. So OH will not be the correct option because OH it is ketoenol tautomerism, that O N nitrogen which is there now, and even double bond also it's not available. So this is not the correct option. And of course 100% B option it is correct, as we mentioned in the reaction. I think you have come to know. And here OH, how come it is double bond? Ketoenol tautomerism it has taken place. Right now this will not be the correct option, and this also the same. And yeah, of course, so option B is the correct option. That is what I just mentioned here, the same thing. 6-membered ring which is connected with water. So you will get what it is, ketoenol tautomerism takes place. So the keto formation it is taking place. Why? Because C double bond C here, what it is, C double bond or keto group, it is more stronger than enol, right? That you know very well. And when it is going keto group, when it is going for the reduction lithium aluminum hydride, you are getting CH2 keto group which is converted to hydrocarbon here CH2. So then you are getting what it is here, NH. Hope you got the clarity. Come on, let us go to the next question. The next question here, that cyano group combined with the methyl magnesium bromide, you're getting the product A in the presence of acid hydrolysis. And that is reacts with the sodium oxyiodide, that is indirectly iodoform test. Right. Okay. So you'll be getting B and C. Now we have to identify A and C. Right. Okay. This is very simple. Usually, I'll give that concept idea trick also. It is a cyano group combined with methyl magnesium bromide in the presence of acid hydrolysis. You will get keto group. Keto group combined with the, what it is, sodium oxyiodide, that is iodoform test, you will be getting what it is, iodoform as well as related salt. That's all, right? Very simple. I just draw the structural formula for you to understand the clear idea. Okay, this is a pentagon, right? Right, this is a pentagon. right? C triple bond N combined with the CH3 MgBr, right? CH3 MgBr. So you'll be getting what it is. This is positive charge and this is negative charge, and the transfer of bond. So here actually is this negative charge which is going to attract towards here. So you'll be getting what it is, like this combination you'll be getting, right? Okay, so here carbon, here CH3, and here double bond N. Okay, so double bond N, and here it is a negative charge. Okay, so this negative charge which is reacts with H plus ion, because H3O plus, no, first it will react with H plus ion. So it will attract towards H plus ion, which is attracted towards minus charge. So we'll be getting like this. Okay, so this carbon which is connected with the CH3, and here a double bond, and here what it is, NH, right? So here again, which is reacts with what it is, water molecules. Water molecules, right? Lone pair of electrons are available. So here what happened? The transfer of bond turns over here this side. Okay, so here you will get the same idea. I just bring it here for you to understand. Here you will get what it is, carbon which is connected with the NH, and here methyl group. I just put it methyl. Okay, here in this hydronium ion which is connected over here. Hydronium, water molecules, no. So hydronium ion, here O, hydrogen, and here hydrogen. So here you will get positive charge. So now what happened? This side, here you will get what it is. I'll draw the structural formula, the next formation. Here carbon, which is methyl group. Here you will get NH2. Why do we get NH2 here? One hydrogen which is shift over here due to that lone pair of electrons. Right. Now here you will get OH, and here you will get H2. So then what you will get, this hydrogen again it will be shifting over there. So you will release that ammonia. You will be releasing what it is, ammonia, NH3 combination, right? So what you will get remaining, that the pentagon, right? Pentagon, double carbon which is connected with the double bond, here CH3. This ammonia NH3, in here one hydrogen is there, no, it will be shift, and you are getting what it is, NH3. So keto group, that is what I just mentioned. Usually cyano compound combined with the methyl magnesium bromide, you are getting what it is, keto group only. So keto group, when it is reacting with sodium oxyiodide, that is indirectly what it is, iodoform test. Okay, now this form we are going to check it, iodoform test. Okay, this is keto group combined with what it is, iodoform test, that is actually sodium hydroxide along with the I2. So indirectly they mention what it is, sodium oxyiodide. So this is what. Okay, so what is the product you will be getting? CHI3 plus, here what it is, the same related salt you will be getting, C double bond O, O minus, related salt. Okay, so you'll be getting, so the what is that product B, and see this is the product B, this is the product B, and this is the product C, and this is the product A. What is it, A? A, it is nothing, what it is? It is a keto group only they mentioned. So indirectly, as we observe the question only, somehow we'll get that idea. Well, if you are thorough in your concept. So the compound A, it is a keto group. Compound C, it is iodoform test, CHI3 iodoform test. Right now, which is the correct option? A. Yes, of course, A option, it's the correct. Yes, iodoform. And B, carbon 14. Now they are asking about carbon 14, where you can identify. So carbon 14, it is there in that middle, here only. So naturally, carbon 14 will be this side only. So this carbon only, cyano group only, no. So here only double bond O. So that means this point only carbon 14 will be there. So this point only carbon 14, this point only carbon 14 will be available. They did not mention anything carbon 14, where exactly will be. Suppose without they mention carbon 14, means option A it is correct. But they mentioned where is it carbon 14 exactly they mentioned, so that we have to go for another option. Otherwise, option A is the correct only, but they mentioned carbon 14, so that is what. So that means here carbon 14 iodoform will not be coming. I mean, this point carbon 14 will not be coming. Only this point carbon 14 will be coming, because this carbon which is connected with pentagon, now that we have to check it. Okay, option C, this carbon 14 which is connected with the next to the adjacent carbon of pentagon. So exactly this point, this option only, it is the correct option. Okay, this also what it is, CHI3. And of course, this is CHO will not be coming. It is not possible at all. How come it is possible? Aldehyde. Actually, a cyano group combined with methyl magnesium bromide, you will be getting what it is, keto group only. So that is another one more concept. So these two will not be the correct option. Suppose if they are not mentioning carbon 14 over here, option A will be correct. If they are mentioning carbon 14, option C is that exactly. See how tricky way they are asking. So option C, exactly correct option. Option A will not be coming because to get that confusion, that is what they mentioned like that way. I hope you got the clarity. How do we go for it? Now, I hope you got the clarity. Cyano group combined with methyl magnesium bromide in the presence of acid hydrolysis, you will be getting what it is? Keto group. Okay, keto group combined with the, what it is? Sodium hydroxide along with iodine, that is iodoform test, you will be getting iodoform. Right. Yes. Come on, let's go to the next question. The next question here, pH, CH, OH, CH3 combined with the PCC, that is pyridinium chlorochromate. You are getting the product A, and then here NH2, NHC double bond O, NH2. You are getting the product B. This is very simple. This is actually what it is, secondary alcohol. CHOH, it is a secondary alcohol. Secondary alcohol combined with PCC, pyridinium chlorochromate, it is a mild oxidizing agent. So definitely you will be getting secondary alcohol. When it is oxidized, you will be getting keto group. When this keto group combined with this compound, so what is the product? That is the question. Simple, very simple. Come on, let us check here. So here I just write the structural formula for you to understand. pH, CHOH, CH3, right? CH3 combined with the PCC. These are all simple idea, but actually this is a JE question only. Now, of course, all this Chouhan's questions, everything, it is based on JE concept only. So it is easy. Number of questions if you go through that. So naturally, you'll be thorough with that concept as well as the way you are understanding this question. Now here CH3. So you will be getting keto group. Now this keto group combined with here what it is? H2N, NH, what it is? C double bond O. Yeah, here C double bond O, C double bond O, NH2. Right now, here one question you can ask. Here this keto group, which is reacts with this. Now, this side also lone pair of electrons are available. This side also lone pair of electrons are available. So this is actually nucleophilic attack only. Now, which side you will get more nucleophile attack? That which side it is more stronger, like a tug of war. If you're going, means which side it will be more strength persons are available. So in that way, the people will pull. So the same way here, this side it is more nucleophile. Here, more nucleophile will be available. Here, less nucleophile will be available. Another question also we have seen in a previous video. You just check it. The same concept only. Right. Now, I just to bring that idea for you. So here H2N, H2N, NH, C double bond O, NH2. So the same thing I just write over here. Why? This water molecules to remove. So when you are removing that water molecule, what is the product you will be getting? So you will be getting what it is? pH, C double bond N, NH, here C double bond O, NH2. That's all. Here CH3, it is a mandatory, right? So this is the product you'll be getting. I hope you got the clarity. And this is a general question. Always they'll be asking without fail. They'll ask this question. So which side that nucleophile attack takes place here? More nucleophile, here less nucleophile. More nucleophile attack only will be taking place. See that option also. You just check it here. Yeah, N C double bond N, C double bond O, NH, NH2. See here they have given that 1, 2. Nitrogen it is available. Here only one nitrogen is available. Actually, where that nucleophile attack takes place, 2 nitrogen side only nucleophile attack takes place. This hydrogen only it will be releasing. That is what purposely I just mentioned. More nucleophile side only that nucleophile attack will be taking place. The next option here PHC CH3 double bond N, NHC double bond O, NH2. Right now here option B, actually what is that, what we have received the same answer only. I just mentioned here. Yeah, exactly. This is the correct option. Okay, option B, actually it's a correct option. Come on, let us check another option also. And CH double bond N, CH3. How come it is possible? This will not be possible. Why? Because here carbon methyl group which is attached over here only. So the answer will be like a carbon which is attached with the CH3, not here. And this is nitrogen which cannot attachment. Okay, so that this will be the wrong option. And of course, this also C double bond O NH2. Where is it? Another one more 2 NH is there. No, so here also this is totally wrong. Right. Okay, what is that compound they have given? NH2, NHC double bond O NH2. Whereas here N C double bond O NH. So this is not the correct option. Okay, I hope you got the clarity. Option B is the correct option. And why this option is correct, I have given that idea. More nucleophile that side only, that nucleophile attack will be take over. Yeah, come on. Let us go to the next question. The next question here. Cyclohexanone reacts with the two molecules of ethyl alcohol in the presence of H plus ion. Product. Usually, what is the product? You'll be two molecules of ethyl alcohol in the presence of H plus ion. So naturally, you'll be getting acetal only because keto group reacts with alcohol. So you'll be getting acetal. That too, they mentioned two molecules. So naturally, you'll be getting acetal only. Alcohol will not be possible. How come alcohol here only? The reactant only alcohol will be available. So alcohol will not be possible. Hydrocarbon, that is alkane, also will not be possible. Only acetal hemiacetal. Hemiacetal, they mentioned two molecules of ethyl alcohol. So naturally, acetal only. Come on, let us check with the reaction. Here it is cyclohexanone combined with H plus ion. So naturally, this H plus ion, lone pair of electrons are available now. So H plus ion, which is attracted towards that lone pair of electrons. So you will be getting like this. So the double bond as it is, double bond OH, here positive charge. So this one, which is connected with ethyl alcohol OH, lone pair of electrons are available. So this also, which is attracted towards what it is, positive charge. Lone pair of electrons, which is attracted towards the positive charge. Right. Okay. Now here OH will be one side, the other side OET. Right. Now this again H plus ion, which is going to hit over here. Right. So here lone pair of electrons, here H plus ion is available. So this two lone pairs of electrons are there, no? So two lone pairs of electrons, this H plus ion losing the water molecule. So it loses H plus and H2. So you'll be getting what it is. This side you'll be getting positive charge. One side OET, the other side it is positive charge. Why? Because it loses water molecules, right? So that lone pair of electrons attracted towards positive charge. So you'll be getting what this H2O. So it loses. So you'll get positive charge over here this side. Again, here what it is, ETOH, lone pair of electrons are available. So the lone pair of electrons attracted towards this positive charge, so you will be getting acetal, both the side OET, right? Okay, both the side you'll be getting OET. So here OET and this side also OET. So this is actually what it is, acetal combination. So the product actually what it is, the product it is acetal. That's what I just mentioned very clearly starting only. So keto group combined with alcohol, two molecules of alcohol they mentioned. So naturally you'll be getting acetal, right? I hope you got the clarity of all these questions, and thank you for watching, and thanks for your great support, and all the best for your JE exams through these videos. I hope this will be helpful for you as you are watching this. Thanks for watching.